Hello everyone, welcome back to my YouTube channel. This is the last and the final part of the generative AI history. So far I recorded two videos. In the first video, I talked about the earlier history of the AI, and in that I talked about the AI versus ML, DL and the generative AI. In the second video, I mainly discussed the language modeling. I discuss about the RNN, LSTM, GRU, encoder, decoder and all. And even I talk about the computer vision, CNN and the use cases related to the CNN and the computer vision. Apart from that, I talked about the transfer learning and the fine tuning. So if you haven't checked those parts, so please go and check. Now let's start with the video. So here in this particular video, I will more focus on the transformer, encoder decoder attention, then transformer, then BERT and GPT and the Chatgpt training. So guys, here this is the notes. Basically, don't worry, I will provide you this notes. I will keep it in my GitHub so that from there you can download. If you don't know about the descriptive learning, if you don't know about the generative model and all, right, so everything I already discussed in my previous video, so please go and check guys. You will get a clear cut understanding. Now in this particular video, I am going to start from this encoder-decoder. Although I already discussed it, but yeah, I will give you the quick overview. I will give you the quick recap of this encoder-decoder. Then I will come to this encoder-decoder with attention, and then finally this ULMFiT, transformer, BERT and this GPT. Okay, so this is today's agenda, and yes, let's start with the encoder-decoder and all. But before that, I would suggest you please go and check with the previous session, where specifically check with this mapping technique, because this is going to be a very important. We have a different type of mapping, why we use it, okay, how to process the data and all, what is the sequence to sequence model, right, and what all task is related, right, what all use cases related to the different mapping. Everything I talked about in my previous session, in my previous video, so please go and check. Now let's start with the encoder and the decoder. So here guys, this is the architecture of the encoder and decoder. You can see in this particular architecture we have two sections. So the first section is called encoder, the second section is called decoder. Now in between you will find out this context vector or encoded vector. So this is the architecture of the encoder decoder. Now I have written some sort of a points over here. So with that point, you will get a clear cut idea. Already I have discussed this thing in my previous session. I'm just giving you the quick recap. Okay. Now here in this encoder decoder architecture, the first thing which we have over here. So let me highlight those particular things. The first thing is called encoder. Okay. The second thing is called decoder. So here we have a decoder. Now in this encoder and decoder, either you can have this RNN, or you can have this LSTM, or you can have this GRU. Anything you can have over here. But in the original research paper, if you will check with the original research paper, so in that you will find out that they are using LSTM architecture, and they are not using a simple LSTM architecture. Actually, they are using bidirectional LSTM architecture. So bidirectional means what? What is the meaning of the bidirectional? So bidirectional means bidirectional is nothing. So bidirectional means you can process the data in both direction, from left to right and right to left. So you can get a precise concept, right? You can get a precise concept of the word, right, which is affected by the future word. So that is the concept of the bidirectional. Don't worry, I will soon I will come up with a dedicated video of this RNN, LSTM and GRU. Here I'm just discussing the history. I'm just discussing the architecture and the overview. That's it. If you want to understand in detail, just wait for some time. I will come up with a detailed architecture and the mathematical explanation. Okay. Now here, if we are talking about the encoder-decoder architecture, so here you will find out. So let me show you that in the encoder-decoder architecture. So you will be having an encoder, you will be having a decoder, and in between actually you will be having this context vector, right? You will be having this context vector. Now guys, why this encoder-decoder architecture was required? So the main reason behind this encoder-decoder architecture was the many-to-many mapping, right? Many-to-many sequence mapping. So this is the architecture of many-to-many mapping. This is the architecture which you can see over here. This one, many-to-many mapping. Now here in this many-to-many mapping, so actually we have two type of mapping. The first is called synchronized mapping. Synchronized mapping means what? Synchronized mapping means a same length. So here you can see the example of the same length. Same length means what? See, many to many, we are talking about many to many. So what is the meaning of many to many? We are passing a sentence from here and we are getting output over here, right? We are passing a sentence over here and we are getting output over here. So both architecture is fine. Both architecture is a many to many and it's a synchronized one. Synchronized means what? So let's say from here we are passing in Hindi, right? So here I am passing I am Sunny and here I am getting मैं Sunny who in Hindi, right? So many to many mapping we use for the language translation. Why we use it? Tell me. We use for the language translation, and that's a better use. This is the like a best use case. This many to many. This is the best use case. This language translation is the best use case of the many to many mapping. So guys, here you will find out that so in this synchronized example, you will find out the same word, right? Same input word and the same output word. Okay, मैं sunny हूँ, I am sunny. 3 input word and 3 output word. But here in the asynchronized one, so this is the example of the asynchronized. Asynchronized means what? Asynchronized means a different length, right? In translation, actually, we have a different length. So here in Hindi sentence, you will find out the 3 word pankha band karo, and here in English you will find out switch off the fan. So this sentence, the translation actually, it is representing to the asynchronized translation. And mainly for solving this task, mainly for solving the asynchronized translation, they have invented the architecture of the encoder and decoder. So let me show you the research paper of the encoder and decoder. So here is the research paper of the encoder and the decoder. The research paper name is sequence to sequence learning. This research paper has been published by this 3-person, Ilya Sutskever, Oriol Binalias Kyok, right? And it was the paper from the Google. Actually at that point of a time they were working with the Google AI itself, and if you will read the introduction and all, you will get the clear cut idea that this was the reason, right? Before, earlier we were able to solve the synchronized problem by using the ILSTM on the RNN architecture, but here we were not able to solve the asynchronous problem, the different length problem, and because of that they have created this encoder and decoder architecture. And the meaning was simple. First we are going to compress everything in context vector, and then we are going to pass it to the decoder for the processing. Okay, that was the intent, or that was the like a base concept. And which architecture they were using over here? So they were using the LSTM architecture, bi-directional LSTM architecture. I hope the thing is clear to all of you now. So I hope this thing is clear now. Here in the research itself, so each and everything I have written, so that I will take a less time to explain you everything. That's why already I have written few sort of some sort of a thing over here, and I have already written it. Don't think that I copied from somewhere and all, right? No, it's I written based on my experience, based on my learning. So research only, in the research itself they have find out that it was this encoder decoder architecture. It was not for the longer text. What is the meaning of the longer text? So longer means if in the sentences I am getting more than 30 to 35 words, right? So the translation was not that much effective. Like we were having the issues in the translation. The translation was not accurate. Okay, so here I have written a reason. So who was using this encoder decoder architecture? So Google was using this encoder and decoder architecture, and they have invented this encoder and decoder architecture for their own product. And the product name was what? The product name was Google Translator, which we all are using. So at that point of a time in 2014-15, they were using this encoder and decoder architecture. Got it? Now what was the solution now? So what is the solution actually? If this encoder decoder is not able to perform well, right? Here it is not able to perform well, then what is the solution? The solution was the encoder and decoder with attention. Encoder and decoder with attention. Now let's try to understand the meaning of attention over here, because this was the game changing thing. And based on that, one more architecture came into the picture, and the architecture name was transformer is all you need, sorry, attention is all you need, that is transformer. Okay, so let's try to understand the meaning of encoder and decoder. So in the research paper, so first of all let me show you the research paper of it. So this is the research paper. Okay, this is the BERT research paper, attention, universal language modeling. Yeah guys, so this is a research paper. And what is the research paper name? Neural machine translation with attention, right? Translation with attention. Which task guys? Translation with attention, right? Encoder decoder with attention. Okay, Now here guys you can see, so attention, what is attention? Now let's try to understand this attention. In this architecture you will find out that we have this encoder and we have this decoder. This red box is actually it is representing to the this red box actually it is representing to the encoder and the decoder hidden state. Now this is the long attention. Actually the original name was a long attention only, which has been written inside the paper itself, you can check. Now here in this particular architecture you will find out that we don't have any single context vector. In the previous architecture we are having the single context vector, but here we don't have the single context vector. So here actually what we are doing, we are connecting each and every hidden state of encoder, each and every hidden state of the encoder with each and every hidden state of the decoder. So decoder is having a information not in terms of single context vector, in terms of multiple context vector. Means every decoder, every hidden state of the decoder is having a information of every hidden state of the encoder. How? Let me show you here. So here let's say this is my encoder part. So I have the encoder, this is my encoder, okay, this is my encoder part, this is the hidden state of the encoder. Let's say I'm using the RNN, just a sake for the simplicity. So here is the RNN cell. Now I'm going to decode the word. The word is what? मैं sunny हूँ. I'm just going to translate it. Okay, मैं sunny हूँ. So here guys what I'm doing, so this is my decoder part. Okay, this is fine. You have a decoder part also. Yes, I am having this. So this is my decoder part, right? Now here what is happening? See, here I am getting I am sunny. So I am sunny, right? So you can think that this is nothing, this is I, and this is am, and here is sunny. Now guys see, this decoder state, it is having the information from each and every hidden state from the encoder. Now this also the same, this one also, this one also, this one also, this one also, okay, this one also. Now this one also, this sunny also, it is having a information from each and every hidden state. This one, okay, and this one guys. Now what is the benefit of it? Actually this is called a attention mechanism. This is called a attention mechanism where I am having not a single context vector, where I have a multiple context vector. Each and every hidden state is having their own context vector, and from there we are going to decide which word is more dominating. Now let me give you one more example over here. So here guys, in this particular example you can see, so I am having switch on the fan. I am having the English sentence, and here you can see the Hindi sentence, pankha chalu karo. Now just tell me guys, this pankha means fan, right? So it is related to which word? It is related to this switch, on, the, and fan. Tell me to which word? So here it is related to this fan. So guys, what I will do, you know, I will provide more weightage to this fan, and I will provide less weightage to this particular words. I will more focus over here. Means, in short, what I can say over here, I am paying attention. What I am doing, I am paying attention to the dominated word, right? I'm paying attention on a like for the dominated word, right? The word basically which is dominating over here, and that was the concept of the attention. And this is the picture which I kept from the research paper itself. Now this is called a heat map. Now here you will find, now one side I am having a English sentence and another side I am having a French sentence. Now here you will see the heat map. Now what is the meaning of that? So here also I have written a meaning. So here the heat map is showing, so more white means strong relation between a word, between the encoder and the decoder word. And here this less white means what? Weak relation, right? Black means no relation, right? So this is the heat map, and by seeing this heat map you can understand which word is dominating to which word in the decoder part, in the decoder side, right? So I hope it is fine. Encoder-decoder and encoder-decoder with attention. Now guys, coming to the next architecture, that was the transformer. Now guys, you will ask me, Sunny, we are having this encoder-decoder architecture with attention. Why they came up with the transformer architecture? Why came up with the transformer architecture? The answer is very simple. Here still we are using the LSTM cell, LSTM, RNN or GRU. Now what was the so how this LSTM, RNN and GRU was working? In a sequential fashion, you know, word by word is what it was processing the data. So it was not feasible for the huge amount of data. Getting my point? The processing the processing was very slow. The second thing is computational uh, it was very expensive. Computationally it was very expensive. Why? Because here we don't have only single context vector. Here each and every word is having their own context vector. For the longer data it was very expensive. So guys, tell me, memory wise also it is very expensive, and here it is it was processing the data sequentially, so it is not feasible for the huge text, and computationally also it is very expensive. Why? Because each and every hidden vector, each and every like a decoder state is having their own context vector from the encoder side. This was the issues. So guys, they came up with a refined version of this architecture, right? They came up with a refined version of this architecture, encoder-decoder with attention. So here guys, the architecture name was the transformer, and guys, this was the major breakthrough of the AI history. Believe me guys. Okay, I will show you why. So the paper name was the attention all you need. Now you can check with the research paper also. So here is a research paper of the attention all you need. This one is a research paper, and it was published by the Google only. So this research paper was published by the Google. I think okay, this is not the original paper. You can search about the original paper with the same name, you will get it, right? And you can go through with the research paper and all. So this is the architecture. I think it's a refined version of the encoder-decoder, because we have so many implementation of this like attention all you need paper, right? Now guys, here this attention all you need, right? So here only attention is required, right? So I have highlighted some sort of a point. Let's try to understand those points, and you will get to know about the transformer. Here again, I'm not going to teach you the definition or the mathematical concept behind the transformer, but yeah, I'm just giving you the overview. So inside this transformer also, we are having two parts. The first part is called encoder part, and the second part is called the decoder part, right? So this is the encoder part, this one, and this one is the decoder part, right? Okay, so you will find out some sort of a thing over here inside the encoder-decoder. So I have highlighted over here. The first thing is what? So here in this particular architecture, they have removed the LSTM, RNN, and GRU. They were not using this LSTM, RNN, and GRU over here. Okay. Instead of that, what they were using, they were using the simple neural network. But how? They were using it along with the self-attention. Now, what is a self-attention, guys? What is the difference between attention and the self-attention? I will come to that. Just wait. I will come to that, right? Now, here, along with the self-attention, they were using one more concept, multi-headed attention, multi-headed self-attention. So this multi-headed self-attention, it was for getting a more context from the sentence, more context, right? Robust, okay, robust processing, more context, right? The third thing was the positional encoding. The positional encoding for maintaining the sequence, parallel processing. Here in the LSTM, in the previous architecture, encoder-decoder with attention, they were using the LSTM, GRU, and RNN, right? There they were processing the data based on a timestamp, SQL processing. Now here we were having the parallel processing. Normalization layer was there, right? For the effective data processing. Okay, we were doing a normalization, and then we were passing data to the artificial neural network, and there were the skip connection also. So this concept they took from the restaurant itself. So these were the changes, these were the thing, this was the highlighted point of the transformer architecture. And here this one is called encoder side, and this is called the decoder side. So all the known thing is here only, right? All the known thing, and this worked in an amazing way, guys, in an amazing way. So here once you will read the research paper of it, you will find out that okay, so initially they developed this architecture just for the language, but now this architecture is applicable everywhere. I will show you some sort of implementation of the transformer architecture. Now here guys, application beyond NLP, I will show you that, just wait. Now here guys, let me tell you a few more things. If we are talking about the transformer, right? If we are talking transformer, so this transformer architecture, the transformer architecture which they have invented, so it was for the huge data. So it will be required the huge data. Okay, then only it will give you the good prediction, right? Now the hardware also was required over here, the good hardware like GPUs and the distributed system and all, right? Distributed system and all. so distributed system and all. Now whatever let's say we are going to transform, we are going to like train the transformer, right? So based on our data, right? So based on a huge data, so it requires the time also, so I highlighted 3 points over here, that why this transformer is why everyone cannot train the transformer from scratch, because of the data, because of the hardware, because of the time. But before that, again I will come to this part, because I have to explain you this ULMFiT, and it is very very important research paper. Now first of all, let me show you the application beyond NLP. So here guys, this is the GitHub which I find out, right? So the GitHub name is what, you can also search awesome transformer, right? So in this GitHub, actually they have highlighted, just go and check with the, and just check with the readme part of it. So there in the table of content, they have defined the different model of the transformer. So some of the encoder based model here, Alberta, BERT, Distill, BERT, DBERT, Electra, Roberta. This is the encoder based implementation, and here these are the decoder based implementation, right? These are the encoder and decoder based implementation, where we are going to connect both things. Now here is a multi-model I told you, right? Multi-model, image to text generation, text to image generation, and these are the model, and which is based on a transformer only. But not till here guys. Here you will find out vision based model also. Yes, what was the task of the vision based model? Image classification, object detection, object segmentation. We can do it by using the transformer, and here is a model guys, DIT, DT, TR, efficient former, and these are just few. You can check more over the Google, right? And there are lots of model you will find out. Now here audio based model for some specific task, right? Whisper is there, Valley is here, and this is a model from the OpenAI side. Recommendation system based model, right? For the recommendation system, P5 is a model. Grounded situation recognition model. So for everything actually you will find out the models, okay, which has been built up, which has been built on top of the transformer itself. So beyond the NLP, but initially they have trained the transformer just for the NLP. They have invented the architecture just for the text to text solution, just for the translation only. But that architecture was the miracle, and yes, I will create one dedicated series for the transformer only, and I will teach you each and everything related to it. Believe me guys, you will learn a lot, right? You will learn a lot, and I will come up with many more tutorials, don't worry guys. And even not with transformer, encoder-decoder, each and everything along with the mathematics. Just wait for some time. Okay, now here guys, here see, the thing was required for training the transformer, as I told you, the huge data, hardware, and the time. It was the time consuming because of the huge data, and then only the transformer, okay, then only the transformer was able to give me a state of art result, right? But how we can utilize it? I told you that this transfer learning, it was possible in CV. It was not possible in the NLP. So how we can utilize the power of the transformer? So here parallelly in 2018, one more research paper has been released, and the research paper name was the, tell me, ULMFiT. Now what is the full form of the ULMFiT? The ULMFiT research paper name is Universal Language Modeling Fine Tuning for Text Classification. Now here guys, let me ask you a question to all of you. The first question is, does TL means transfer learning possible in NLP? Does fine tuning, FT means fine tuning, is possible in NLP? How? Yes, it is possible because of this research paper. So parallelly we are having the transformer, the architecture, the encoder-decoder architecture, and the other side, this side, we are having this universal. Parallelly, the paper released in 2018 itself. Now here guys, you will find out this, inside this ULMFiT paper, there were two stages of the training. The first stage of the training is called Universal Language Modeling, and the second stage of the training is called fine tuning for the text classification. Now guys, this is going to be very very important. Just focus now. So universal language modeling, what is the meaning of it? So the meaning of it, tell me, unsupervised pre-training. And what is the meaning of it? Fine tuning for text classification, supervised fine tuning, right? Now here guys, let me go back with the language modeling. So I was talking about the language modeling, and we were having the different tasks: text classification, text generation, text summarization, text translation, right? We are having the different tasks. Now here you will see in this particular architecture, so I think in my previous video also I have shown you the same thing. So let's say we have a model. This model can be anything: LSTM, RNN, and GRU. So let's say we are giving a data to this model. We are training the model, right? We are doing a training. Now here, guys, this training, actually, it's called a supervised learning. We can take any sort of a task. So let's say we are taking a task of translation, right? Translation. So here, guys, we are taking a task of the translation. Means one side we have a English sentence, let's say Hindi sentence, or English basically. Let's say I am Sunny, and here the translation is मैं Sunny हूँ. Likewise, we'll be having lots of data, and yes, we can train our model. And this is called, guys, tell me, this is called supervised language modeling. Any sort of a task you can take. You can take the text generation, you can take the classification, you can take the summarization, you can take this translation. If we are talking about the next word, if we are talking about the generation, let's say next word generation, so how it will work. So let's say this is my data, I am Sunny Savita, right? So how I will prepare the data, over here. So I will be my independent column, M is my target, then M will be my target value, then M will be here, the Sunny will be here, then Sunny will be here, then Savita will be here, and based on this Savita, so it will try to predict the next word like this. So we are going to train on this particular data our model, and we are going to predict the next word. Supervised language modeling. So here, guys, this is called supervised language modeling. So here what I'm doing, tell me, in this one I'm teaching to my model, I'm training to my model, I'm teaching to my model, right? But guys, here this supervised modeling, actually this is just for the discriminative learning. This is called a discriminative model, and I told you about the discriminative model. So for the discriminative model, less data is required, right? Like we'll be having a less data or specific data, and it is just for the specific task. It's specific task only, right? It is not for the generative. Now, guys, for the generative, guys, more data will be required, and it is going for the generative. It is going for the general task, right? Now here itself, this LLM concept comes into the picture. Large language modeling. But how it was possible? Because of this research paper. Because in this research paper, what they have introduced? They have introduced the concept of the universal language modeling. This universal language modeling is nothing. It is called unsupervised pre-training. Now what is the meaning of it? So here I have written unsupervised language modeling, unsupervised pre-training. So before we were doing the supervised language modeling, supervised learning, now unsupervised language modeling. Why, guys? Why we are doing it? Because let's say we have a data, we collected lots and lots of data from the internet. If I have to do the supervised language modeling, in that case I will be required a label. So tell me, guys, is it possible to put up those much label? Tell me. Let's say you collected 100 GB of data. Can you put the label on the 100 GB of data from the internet? No, you cannot do that. That's why supervised language modeling was not possible. And in this research paper, they have introduced the concept of the unsupervised language modeling. Now, unsupervised language modeling based on this three things, right? So here, huge data was there and label was not possible, right? Now here, guys, huge label was there and the a labeling was not possible. Now this unsupervised language modeling, they were doing based on this three things. First is statistical pattern. They were trying to find out the statistical pattern from the data, right? Distribution, they were matching the same distribution from the data. They were trying to segregate the data. The second thing, semantic word. They were trying to find out the semantic word. They are trying to find out the relation between the word. And they were finding out the contextual relationship. Contextual relationship means what? So they were taking the length of the sentence and they were trying to match with the other sentence. They were taking the length of the sentence, they were trying to match with the other sentence. Based on this technique, this three technique, they were able to perform this unsupervised language modeling. Now, if we are talking about the language modeling, there are so many tasks: generation, translation, summarization and all. But in this specific paper, which task they selected? They selected this next word prediction, text generation, data generation. Getting my point, guys? Yes or no? Yes or no? Tell me. I think yes. And this thing is called unsupervised pre-training. And because of this, Because of this, they have trained the huge model, huge language model, right? Large language model. Getting my point? Yes or no? So here, this huge data means large. This huge data means large language model. How, guys? How? Based on this unsupervised language modeling. Right? Why, guys? Why they selected this task? Next word prediction. Next word prediction. So that we can map word to word, word to word. So my model can learn. Here I have written it. My model can learn, and based on a previous word, we can predict the next word. They have checked with the machine translation also, but it was not working. Machine translation. They have created a like a one column, another column, right? So one column for the other sentence, one column for the other language sentences and all, right? But it was not working. The model was not able to learn. Then they took this particular task, next word prediction, and the model was learning very, very good. So the first step was the unsupervised pre-training or unsupervised language modeling, which was the main aim of this paper, unsupervised language modeling. And then supervised fine tuning means we are training the model after like a language modeling. After doing a language modeling, after teaching the language to the model, now we can train the model on top of any task. So there were two stages of this particular paper. I hope you are getting. Now, guys, transformer is there and ULMFiT. That means the power of the unsupervised language modeling is here, so that we can train the model on a huge amount of data. We can teach to the model and we can train it on a specific task. And because of that, these different architecture came into the different architecture came into the picture. So the first architecture which I have written over here, that is a BERT, and the second architecture which I have written, that was a GPT. And after that, we'll try to understand the training of the Chatgpt. So let's start, guys. Let's start with the BERT. Now here you can see we have so let's start with the BERT. So what was the BERT, guys? So BERT, actually, it was also the language model. It was also the language model. So here let me write it down that. So it was also the language model. Language model means what? So which has been trained on a huge amount of data. Huge amount of data. So huge amount of data. Now how they have trained it? With the same thing, with the same concept, unsupervised language modeling, ULM, unsupervised language modeling. Now here, guys, BERT, it was the encoder only model. So here also I have written it, and it was the project of the Google. It was the project of the Google. So this encoder, this part, this particular part, actually, this part. So this is called the encoder, and here this is a BERT, actually, and this decoder part, this particular part, this is called this is called a decoder, and this is nothing. This is a GPT. So I will come to the GPT. Don't worry. So this BERT, actually, it was trained with the same thing, with the same concept. That's concept of the unsupervised language modeling. So where first they were training the model on a huge amount of data, right? They were teaching to the model. Right? And how they were teaching, with which task? Tell me. They were teaching with the next word prediction. They were teaching to the model. With the next word prediction, guys. Please remember this thing, right? So it was the encoder-decoder model. Now here, guys, this BERT, actually, it was using the MLM. So MLM means what? Mask language modeling. I will come to that. What is a mask language modeling? Then it was using the next word prediction and next sentence prediction, this particular thing, right? So masked language modeling. By using this masked language modeling, it was doing this next word prediction and the next sentence prediction. It is also doing the language modeling. So here, if we are talking about the language modeling, so the first is unsupervised pre-training and the second is supervised fine tuning. So this is a language modeling, and because of this only, like, you are able to see this LLMs, large language model, because first by using this unsupervised pre-training, we are training the model on a huge amount of data, and then we are training it for a specific task, right? Later on, we are training it for the specific task, and that is a difference. Actually, this is the difference between discriminative model and the generative model. So in the discriminative model, the data and the task will be specific, but here the data is not going to be specific. The data will be very, very huge, every data, and the task also is not going to be as specific. It was the general task, anything it can do. Why? Because it has learned the language. It understood the basic concept of the language because of that only. Got it? So language modeling was there. Now this board actually, it was a bidirectional model. So this encoder itself, it was working in a both direction, in this particular direction and in this particular direction. Why we do it, guys? For capturing the the board, we want to capture the input from the board direction. That's why we do it. Okay, that's why we do it. So here bidirectional modeling was there. Now for what all use cases they have created the board, the Google has created the board. For the sentiment analysis they have created, for the NER, right, for the name entity recognition, for the POS tagging, part of speech tagging, for the question answering actually, right, question answering and all. For solving this particular task specifically they have created the like a bot, right? So now let's try to understand the concept of the mask language modeling. So this is the architecture actually, this is the architecture of the mask language modeling. Now let's try to understand how it works. So let's say here is a sentence, I'm writing one sentence over here. The sentence is very, very simple. Here I'm saying my name is Savita. Okay, Savita. Then I am scientist who is working in Bangalore. So this is the sentence. Now here, guys, my name is Sunny. So here I am writing Sunny. Here I am data scientist. So data scientist, right? So this word actually, this word, it's a mask word. Okay, this word is a mask. I'm doing a masking of these particular words. So based on this word actually, based on this word, the previous word, we are trying to predict this thing. Based on this word actually, this word, okay, this particular context, we are trying to predict this thing. Did you get? Yes or no? What we are doing a masking in between the sentences, in between the text. We are doing a masking randomly we are doing it, and based on the around context. So my name is Sunny Savita, I am data scientist. So Sunny is masked word. So based on this particular thing, we are trying to predict this word. Unsupervised fine tuning, we are trying to read the semantic meaning, contextual meaning over here, contextual relationship. We are trying to understand the distribution of the words. Distribution of the word means frequency. Okay, frequency of the word, how frequently it is coming and how it is related to the other word without any label. So this is called mask language modeling. And after this mask language modeling, here you can see this is the mask language modeling, mark sentence, this is the mark sentence, this one. And then we were doing the fine tuning on the question answering data set, question answering pair. Okay, here is a question, this is a question, and this is the like a questions and all, and here related to that we have a answers. Okay, question answers. Now we were doing it on top of this squad data. It's a very famous data, right? SQUAD, squad data, right? Now I think this is clear, and then we can download the BERT. We can download the raw BERT also. Raw BERT means this language model also, and we can download this fine-tuned models also. We can download the raw model and we can train according to our requirement, and we can download this fine-tuned model also. Both are fine. Okay, so BERT is clear. Now here I'm just giving the overview, so I'm just restricting to my explanation. But yeah, once I will create a dedicated video, in that I will explain you each and everything. Now guys, here the next thing was the GPT, and this GPT actually it's changed the history. Now here related to the GPT, what is the full form of the GPT? Generative pre-training. Now here we have a 3 variant of the GPT. So the first variant of the GPT is called, so here is the first variant, improving language understanding by generative pre-training. Improving language understanding by generative pre-training. What is the meaning of it? Same thing guys, same thing. Unsupervised learning, unsupervised language modeling, where we are giving a power to the model so that it can learn something, right? It can learn something, it can learn the language. How? Tell me. Next word prediction. Same thing. You can read over here. The term is generative refer to the model capability to generate coherent and contextually relevant text. Pre-training indicate the model initially trained on a large corpus of the text data in an unsupervised fashion, and then we are going to fine tune it for the specific task. Same concept, ULM, unsupervised language modeling, and then fine tuning, unsupervised ULMFiT. You know na, that paper ULMFiT, right? Same concept. So over here, the first paper was the improving language understanding by the generative pre-training. The second paper was the language model are unsupervised multitask learner. So here, so in the context of GPT-2, the term unsupervised multitask learner refer to the model ability to perform a variety of natural language processing tasks. Why, guys? Why? What is the reason behind that? Tell me. Because they have used a huge amount of data. The model was more capable now over here without task specific supervision during the pre-training phase. So here, guys, in the pre-training phase itself, in unsupervised learning, they have given lots of data to the model, lots of data. It got the billions of the parameter, and because of that, it was a multitasker. It can perform anything, and we all know the power of the GPT here, right? So GPT-2 is designed as a large scale language model that is a pre-trained on a diverse corpus of the data. Same concept, ULM. Okay, ULM on a huge data, guys, right? Now coming to the GPT-3, this is the Papa G of all the model. Okay, this is the Papa G of all the model. Why? I will tell you. So GPT-3 actually, it's a language model or few shot learner. What's the meaning of it? It has been trained on a very, very huge amount of data, which is having around 175 billion parameter. And here, to this language model, you just need to provide a few short prompt, right? Zero shot. I will come to the zero shot in my upcoming session. Few short prompt with a minimalistic information, and it will give you the output. It will generate the output without any supervised learning, and this is the power of the GPT. Now here I have written the differences between, actually I kept the differences between GPT 1, 2 and 3, so that you can understand each and everything. So here, guys, model size 117 million, 1.5 billion, 2 and 3, you can see 175 billion. Context window limited due to model size. The context window means the sentence window, the sentence, how much word you are selecting for predicting the next word. That is the meaning of context window. So it was larger, and it was extremely larger. We can take a huge amount of like a large amount of words, the longest long sentence basically, to predict the next word. That is the meaning of it. Now fine-tuning capability limited here, improved and enhanced, right? Now here release date 2018 along with the transformer model, 2019, right? 2020. And prompt engineering limited here, more influence as substantial, downstream task performance, less impressive on specific tasks. Now improve performance on a diversified task, exceptional performing on a wide range, because here the data was very, very huge, right? Downstreaming means what? Supervised fine tuning, which we are doing now after the language modeling. Fine tuning we are doing after the language modeling. That is the meaning of downstreaming tasks. Now here ethical consideration. So that is very much focused. This GPT-3 is focusing very much on top of that. We know about the Chatgpt, right? So research impact, pioneering large scale unsupervised learning, advanced understanding of transfer learning, broader application we have of the GPT-3. Use cases, so here it is having a more use cases because of the large model, right? So public like access, yes, GPT-3 we can access by using the APIs, GPT-2 and GPT GPT-1 also. Nowadays no one is using, everyone is using the GPT-3 by using the OpenAI itself, because it's a model of the OpenAI. So I hope, guys, you got to know the differences and you got to know the meaning of the GPT also, and it was based on the unsupervised language modeling. Now, guys, the next thing here, training of the Chatgpt. Now let's try to understand the training of the Chatgpt. So the very first thing over here, guys, just focus. They are taking a data from the internet. And that is a huge data. And here, guys, this Chatgpt is nothing. This Chatgpt is a application, right? And behind this Chatgpt, they are using GPT-3 model. Actually, the variant of the GPT-3, that is 3.5 turbo, or recently they have introduced one more model, that is GPT-4 and 4 turbo. So, guys, this Chatgpt is nothing. It's a implementation on top of this application is an implementation on top of GPT itself. And now we know about the GPT. It is taking a huge data. Generative pre-training. What is the meaning of it? Unsupervised language modeling with the statistical concept. with a mathematical concept. Getting my point? So here we taught to our model. We given the every knowledge to our model with a huge amount of data. Then supervised fine tuning. Supervised fine tuning means they have trained this GPT 3.5 model, means after this 3, right, the 3.5 model came into the picture. Specifically they were using for the Chatgpt training, right? So the concept, specifically the concept is all supervised fine tuning. So they are fine tuned over here based on the question answering data set. So there was the question and there was the answer, there was the question, there was the answer. Okay, so here they have trained it based on a conversation. And then the last concept, you know what was that? So the last concept was the reinforcement learning, and that was a very amazing concept, guys, which they have implemented. So guys, did I include it over here? Yes, for sure I have included that thing also over here. So see, first is supervised fine tuning. So as I told you that they have trained the model later on a conversation data. So here is one human which is asking something, and here is the another human which is responding something. Now from where you will get this type of data? So you will get this type of data from Quora, right? You will get this type of data from Stack Overflow. You will get this type of data from the Facebook comments, Facebook and Insta comment. You will get this type of data from the Reddit, right? Reddit. So on top of the huge amount of question answering data, they have fine-tuned this model. They have fine-tuned this model, and because of this only, it is able to make a conversation. They have built up the conversational AI. Getting my point? Yes or no? I think yes. Okay. Now this was the fine-tuning, and here guys, they are using, you know, which model? Transformer model only, the decoder part of the transformer model. So after this guys, so reinforcement learning was there. Now what was the reinforcement learning? What is the reinforcement learning? First of all, let's try to understand the reinforcement learning. So here guys, this is the diagram for the reinforcement learning. So in the reinforcement learning, you will find out one environment. So this is my environment. Then we have an agent. This agent is performing some sort of a task, and based on this task, actually it is getting reward. Either it is getting reward or it is getting the penalty. That is the reinforcement learning, and we have a different algorithm over here. So algorithm wise, you will find out the Q star algorithm, right? Q learning algorithm is there, or deep Q learning, right? Deep Q learning. So different like algorithm you will find out. Q star or Q learning algorithm, right? Q learning is also there, and different algorithms. So just search about the reinforcement learning and you will get it. So this is the summary of the reinforcement learning. Now how it was working over there? So it was working. So here you can see the complete implementation. So this chatbot is asking something, and here this human agent is asking something, and here the chatbot is replying. Now whatever responses actually we are getting now over here, whatever responses, so it is giving a rank to those responses, right? So based on the rankings from worst to best, okay, accordingly again it is going to be trained it. So just see over here, we are having a agent is nothing, it's a Chatgpt, okay, Chatgpt. Now here is an environment, means this is the complete application. Now we are asking something to this Chatgpt, to this agent, right? Let's say we ask something and it is giving a answer. Okay, it is giving an answer. Now over here, let's say it is generating a multiple answer, 1 answer, 2 answer, 3 answer. So it is ranking this particular answer based on a it is ranking this particular answer based on a feedback. So that's why this is reinforcement learning through human feedback. Now from where it take the feedback, I will show you that. So it is ranking the answer based on a feedback, and here this is the first answer, second answer, and third answer, like this. So this is going to be their reward and penalty, and according to that again it is going to be trained, this Chatgpt, right? Now let me show you where you will find out this type of thing in the Chatgpt itself. Now if I'm opening the Chatgpt, so here guys, you can see, let's say if I'm asking something to my Chatgpt, I'm asking, hi, can you tell me something about the AI. So here it is giving me answer. See, now here if it is generating, so it will take time. I think it is generating a huge answer. Now see, I got an answer. Now here it is asking the human feedback, right? Whether it's a correct or not. So let's say if I'm saying the bad response, here I'm giving a ranking to this one, bad response. Now I'm saying that this is not true, right? So here I'm submitting the feedback. Now see, this is the new answer and this is the original answer. Okay, So what happened actually, the agent means ChatGPT asked I asked something to my ChatGPT, it is giving me answer, it is working in a particular environment, it is giving me answer, this agent means ChatGPT is giving me answer. Then here, based on a human feedback, means the feedback which I have given to this one means the reward or the penalty. So reward means it is fine, but I have given the penalty means this answer is not correct, right? And based on that, again it has generated the answer. Now in backend actually, what you know what it is doing, it is ranking this answer. Okay, it is ranking this answer, and because of that only it is minimizing the error, it is minimizing the error. And automatically this thing is happening by using the reinforcement learning, by using the reinforcement learning. Okay, so I hope this thing is clear. Now again it is asking to me, so new is better, original is better. So here I can say neither is better. So it will I told that neither is better, so again it ranked the like output. So again I'm giving a like a thumbs down over here. So bad response I'm giving, but it is not taking. So actually it is not working over here, maybe I will have to regenerate it, something like this. See, once I regenerated, so I got the third answer. Now I can give the thumbs down to this one also, and according to that it will rank it. So I hope you got it guys, what is happening over here. Now how it is working, this reinforcement learning and all. Now I have written couple of things as well related to this ChatGPT. So it is following the ethics. Actually you cannot give the unusual word or any abusive word to this ChatGPT, and it is a very good thing. Now here it is maintaining the memory. So if you will ask anything to the ChatGPT, if you will shut down the chat, then again you will go back to that, and again like you will start that conversation, definitely it will be able to remember that. So they have provided you this functionality also. Dialogue specific training means they train on the like conversation data. So they took the conversation from the different platform, and the dialogue is, they perform the dialogue specific training over there, right? So this plays a very important role. This RHFL means reiterative feedback, right? Reinforcement learning through human feedback, this also played a very important role, and because of that it is able to minimizing the error, we are getting a minimized error. So got it guys, this is all about the ChatGPT training. Now you can go through with it, you can revise it, and this is the end of this series, the history of the generative AI. I hope you learn a lot. Now here let me tell you the conclusion, that what will be the conclusion of all this thing, right? So guys, I started with the AI, ML, DL and all, then I came to the generative AI, where we have understood that this generative AI is going to be a future, because here actually it got famous, very much famous from this LLM itself, from the large language model itself, and the base was the transformer. Then person or the researcher actually, they have seen the capability of the transformer, this attention all you need research paper, right? Here I have opened the different research paper guys, and it is going to be a very important. So see, OpenAI models is also there. So chat GPT-4, GPT-4, GPT-4 turbo, GPT-3, 3.5. In future I will discuss all this thing, right? GPT-4b is also there for vision, for the text data and for the images data and all, right? You can provide the images and all. Now here you will find out this neural machine translation paper, it is also very important. This universal language modeling, this is also very important. Now here this transformer, this is the very important paper, attention is all you need. Then this is the paper like BERT is also very important paper. So before starting with the generative AI and all, you definitely you should start with this particular paper. It will give you the a lot understanding, the like a lot understand a lot like a knowledge and all related to the generative AI and the different models and all. Then guys, we understood that over here we understood this transformer is a backbone of everything, and this is not applicable for the text only, right? This is not applicable just for the text. Actually we can implement this transformer for everything. We can implement for any sort of a task, like a heterogeneous task, for the multimodal task. Here specifically I'm talking about the generation task, right? And here we can use it for the vision task also, for the vision related task also. Okay, so vision related tasks like a detection, segmentation, or the image classification and all, we have so many implementation of it. Now this field is evolving on a day by day, and you will find out so many things over here in upcoming like a year, and in within like 2 to 3 year itself. So guys, yes, definitely it's the future of the AI. It is not a complete AI, you will find out so many things in your upcoming days, right? The general AI and all. So in another video I will be talking about it. But guys, it's going to be a very important, this large language model. The new term also came into the picture, large image model, Why? Because it is able to process the image, it is able to process the, it is able to generate the image. And we are having a different models like Delhi, okay, Mid Journey, okay. I in future I will talk about the Mistral and all, everything I will be talking about here, right? And each and every time I will be clarify. So I hope guys you like this series, you like this like history of the generative AI and all. I covered in very detailed way. So guys, please stay tuned with the channel. If you're liking the content, then please hit the like button and please support the channel. I will be coming up with many more things. So yes, we will meet in the next session, in the next like a video. So until guys, thank you, bye bye, take care, have a good day guys, thank you.